Okay, last time we already get through that. Okay, that means you get along with the sine wave. What if we pick, you pick VIMS or VAC, period frequency. Okay, and this is a capacitor. Okay, I think you know. Okay, and they're telling you okay the value of the capacitor basically a farad, and also you can get millifarad, micro, nano, pico. And that one showing you the capacitor charging. Okay, that means at beginning the zero, they keep charging up until the voltage on the capacitor the same with the power supply here, and they no longer charging. Okay, that will be the charging. Okay, when the capacitor gets the full charge in here, that means the voltage on the capacitor and the power equal, then the current flow here will be zero. That's only thing you need to know. And you get the time constant, tau equal R times C. In this formula, R in ohm, C in farad, tau in here, in second. Now, what that means for time constant? Time constant is the time for capacitor charge of discharge to 63.2% of the maximum value. That is the definition for the time constant. And the time constant equal R times C. Okay? And then this is discharge. Okay? If you can see, this is the E, that maximum voltage on the capacitor. And when they discharge, they keep going down until zero. Okay? And this shows you charging and then discharging. Okay? The rate of capacitor charge it depends on the product RC. Okay? Time constant is the time for capacitor charge up to 63.2% of its maximum value. After 5 time constant, the capacitor is full charge. Okay? And in here, this is a formula try to calculate the time. Okay? RC log 1 over 1 minus delta VC over E. And they also explain to you delta VC, that means change in capacitor voltage over period of time t. That means the voltage difference between initial voltage on capacitor and the total voltage that it is trying to reach. And small e natural log equal 3.7. The time that the capacitor is allowed to charge R in ohm C will be infinite. But I'm not asking you try to do the calculation. We don't care about that. Only thing that we really care is the capacitor charging and discharging, okay? And how long they can be full charge. If they full charge, what happened to the current, okay? Okay, for this example here, okay, we already talking about last time. I just quick go over. So make sure you guys can follow it. If they close this one, so the current from E will be charging capacitor. Okay. After the voltage on the capacitor charging up equal to 40 volt here. That means this side 40, this side 40. Then the no more current flow. Okay. In here, they want to calculate the time constant. How? Okay. We already telling you. Tau equal R times C. Okay. And the next one, VCF, the time constant. Okay. You understand what the time constant? Time constant, that means the time for the capacitor charge up to how many percent? We already telling you in here. Time constant is the time for capacitor charge or discharge up to 63.2% of the maximum value. So VCS time constant, okay? That means the voltage will be charged up to 63.2%. So 63.2%. And we already calculate, okay, tau here, okay? Let's see. The answer will be time at time VCS time constant. Okay. That means you get 40, okay, times 63.2 divided 100. Time for VC, reach for volt. I think that is a formula. RC log 1 over 1 minus delta VC over E. Okay. R you know, C you know. delta VC means reach for volt, divide E40. Okay? So basically, you calculate it, you can get the value. Okay? VC at 4.17 volt. I think that will be the same. This is what I want you to know. Capacitor connect in series. C1, C2, C3. Okay? Now you want to combine 1, 2, 3. You only want total. Then the formula applied will be exactly the formula applied for resistor in parallel. Okay? That means 1 over C1 plus 1 over C2 plus 1 over C3 and so on. However, if you get only two capacitors parallel, then same parallel resistor to resistor C1 times C2 divide C1 plus C2. Okay? And now it's a capacitor connect in parallel. If you want total, they will be the same like resistor in series. C1 plus C2 plus C3. Okay? Like resistor in series. R total equal R1 plus R2 plus R3. Okay? For this circuitry, okay, they want the total capacitor. Look from here into circuitry. And the first thing what you have to do, 45, 15 parallel, you can combine. Get what? C2, 3, C2 plus C3. This parallel combine, you get another one. Okay? So, first thing, you get a C1 and C2, 3. Combine this guy. C4, 5. Combine this guy. So now you can get C1, C2, 3, C4, 5. They in series. So you want to calculate the total C will be equal 1 over C1 plus 1 over C2 plus 1 over C4, 5. Answer will be 12 microfarad. Capacitor current and voltage during charging. Okay, we already.
Can you go
Okay,
back for
okay.
1 minute? Just
Yeah.
go back for one quick minute for me.
Go back here.
Yeah, just for 1 quick minute.
Okay, basically you're looking from here. Into, then the job you have to do. This guy and this guy parallel. You combine to get what? I call C2, 3.
Right.
That means they parallel, just add them up, C2 plus C3. Then the second guy, here and here, parallel. Combine it, add them up, then you get C4, 5. Now the circuitry will be look like C1, C2, 3,
Right.
C4, 5.
Right.
Now you want to calculate the total. you have to using the formula like resistor in parallel. 1 over C1 plus 1 over C23 plus 1 over C45. And the answer will be 12 microfarad.
Okay, thank you.
Welcome. Now, on that one here, okay, when the capacitor full charge, the maximum current, okay, current here, and then now they discharge. So the current will be going down until no more current. That means zero. Current sub during charge. Current is zero when fully charged. This is charging voltage. At the beginning, zero. And they charge. They cannot go right away. They need a time for capacitor charging keep going up to a certain point. The voltage on the capacitor equal E. That means no more current flow. Okay? So this is the full charge. Capacitor voltage VC equal E when full charge. Okay, now try to get along with that thing. Zero here. That will be 90 degrees. That will be 180 degrees. 270. And that will be 360 degrees. You see that? That's a sine wave. And sometimes they're using the radian. Okay? 300 degrees equal 2 pi radian. So pi over 2, 90 degrees. Okay? 180 degree equivalent pi. Okay? 3 pi over 2 equivalent to 207. 2 pi, that will be 306 degrees. So basically, they're talking about omega t and f. Omega t basically equal 2 pi radian. Okay? And finally, omega equal 2 pi f. Note that omega is referred to as radian frequency. Okay, we don't pay much about the radian. Okay, capacity circuit. When AC signal applied to the capacitor circuit, the capacitor creates a resistance called a capacitor reactance, XC. Okay, you understand the capacitor will be open for DC. Okay, and basically they will be shorted for AC, that form electronic. However, when you get the AC and the capacitor, they can get resistance. The resistance, that's what they call a capacity reactance, XC. And this is the formula to calculate the resistance of capacitor. X equal 1 over 2 pi FC. In this formula, pi equal 3.142. F will be in hertz, C will be in farad. The relation between capacitor voltage VC and the capacitor current IC. This is the formula. For purely capacitor, capacitor circuit. Current lead voltage 90 degrees. This is the formula. Okay. IC lead VC. That's what you have to know. Now you see they draw it here. This is the IC. Okay. And the red one is the VC. Someone will looking into here, then try to recognize IM or VM, that means IC or VC. Which one is leading? I'm telling you. IC here get into the domain at 90 degrees, pi over 2, 90 degrees, before the red one. So that's why they telling you IC lead VC by 90 degrees. Okay, let's see. Remember, this is the formula to calculate XC. Okay? For the circuit shown in figure number 1 here. Calculate the capacity reactance. So XC equal 1 over 2 pi FC. We already did it. We calculated, okay? They equal 4.24 kilo ohm. And then they want to calculate the current I, okay? I equal VT divided XC. That's just Ohm law, okay? That's what you get for milliamp. For the second circuit, okay, on that one, capacitor reactance XC, okay, they given you the current I, okay, and they want to know what XC equal. You get the V total and the current, Ohm law, XC equal VT over I, okay, and calculate C, okay. You know the formula XC, right? XC equal 1 over 2 pi FC. In this formula, you already know XC. You already know 2 pi. You already know frequency. Then you can calculate C equal 1 over 2 pi F times XC. We already given to you calculation. Now, the series connected capacitor above calculate the total XC. Okay. XC. When they get the value XC, that like resistor. So that's why you adding XC1 plus XC2 plus XC3 like are in series and parallel. Then they calculate the same like are in parallel. You see what the difference? If they using C, C1, C2, C3, you want to calculate the total, they will be opposite to the R in series formula. However, when they're using XC, that means the value will be ohm, kilo ohm, whatever. Then they will be working like resistor. Okay, XC and R. Now you get a circuitry. The circuitry, you get a total voltage. This capacitor, they given you value XC, not C, XC. And they given you the value R for resistor. So basically, capacitor and R in series. Okay. First thing, I explain to you, current IT is the same on component. That's correct. That current IT flow here. Go to C, XC, go to R, same current. Okay. The IC lead VC by 90 degrees. This is a key point. Try to understand. Then later on will be no problem. Okay, in this circuitry, R and C here, one thing you know, IC okay, that's the one thing we already knew it. Now, I and R, what the different phase between I and R? IR and VR.
Are you talking about the IC is leading VC by 90 degrees and the VR is also leading VC by 90 degrees so that IC and VR are actually in phase? Is that what you're talking about? Or
Now, what I'm talking about, resistor, right? IR and VR all the time have to be in phase. They don't have a different phase. This is the key point here in order to understand AC. After that, everything will be easy. Okay, if you're talking about capacitor, you have to understand the IC current. That means the capacitor current all the time lead capacitor voltage by 90 degrees. Okay, that's the first thing. Second thing for resistor, current on the resistor and the voltage VR all the time, they will be in phase. They don't have a different phase. That's the key point. In order you can see what's going on here. Okay, now on the second one, VR in phase with IT. How? How they say we are in phase with the I total?
Is it because of voltage, resistance, and the current resistance are in phase?
Okay. We'll see. IT, IC, IR. Only one I. Correct? That means the current flow here. IC, IR, or we call IT. That's only one current, right?
Right.
I total. That is the same thing with IC. The same thing with IR. The thing is we get only one current. Okay? So that's what how come they say we are in phase with IT? The thing is, IR in phase, and IR, same thing IC, the same thing IT. So that's why they're talking about VR, okay, with the current IT. Now, next the IC lead VC90. That is the formula. VR and IT are in phase. That will be up to VR lead VC by 90. That's what you come up with. VR will be lead VC by 90. How come they say VR lead VC by 90? Only thing you know will be IC lead VC 90. And now they say VR lead VC by 90. How? The thing is IC or IR. Same, right? You see that? Only one current.
Yes.
IT, IC, IR. And now, if I say IC lead VC 90, okay, that will be telling you IR also lead VC 90. Correct?
Yes.
Okay. You can say IR. Lead VC 90. And II and VR. What the phase difference?
There is no difference. They're both in phase.
They in phase. So that's why they come up with they're telling me VR lead VC 90. That's what they're telling you in here. VR lead VC 90. Okay, summarize on that. You know IC lead VC 90. And IC and I are in phase. So IR also lead VC 90. And IR and VR also in phase. That's why they come up with VR lead VC 90 degrees. Okay. VC will be equal IT times XC, just Ohm's law. XC now the value will be O. Okay. IR, same thing. VR, IT times R. Just on law, same thing. IC and R must also be 90 degrees out of phase. IC and R, not the same phase. They different. Okay? VR lead VC 90 degrees. When you can understand that thing, will be help you a lot. Now, ICNR in series. Okay? You get IC equal 80 ohm, R 60 ohm, and the VT 100 volt AC. Now, first thing, I understand this thing. Okay? This is X, okay, coordinate, this is Y. You understand this is 90 degrees, right? Okay? If you going from here, that 90, go that one, 180. You keep going that one, angle will be 270, and you go back to here, 360 degrees, out phase. That's a full, okay? Now, first thing, okay, we draw for vector for R. Okay, R will be 0 degree different, no phase. So that's why you draw that one. That vector for R. Okay, and now we already know R leading XC 90 degrees. So if you go up or you going down, okay, go up, that means leading R. Going down means lagging R. Okay, so that's why you draw first one, ER. Second one, XC going down. Okay, guarantee, make sure you understand how come we draw that one this way. Again, you draw vector for R this way. Why? R has no degree different, no phase. Okay, and R is leading XC, we already telling you 90. So XC must be going down. Okay, and now you can draw for phase yaw here. First thing you draw for R. Okay, and now XC going down. You draw XC. Okay, when you connect here, draw that one. You get the total impedance, Z total. Okay, and the angle in here, theta. Okay, now, that's what they call rectangular coordinate. So, you want to calculate the yield total resistance. Why you cannot adding XC to R? Why? You know series resistor, total, just add them up. However, in this case, calculate the total, you have to take a square root of R square plus XC square. This basically coming from that one here. My question is, why you cannot add 80 ohm to 60 ohm.
They're not in phase.
They different phase. Okay? They different phase. We already telling you. R and C are leading C by 90 degrees. Okay? They're not like normal resistor in series. So that's why, based on this phasor here, you can calculate GT equal R square plus HC square root, okay? And the IT equal VT divided GT. VR equal IT times R. VC equal IT times HC. That's normal. Okay, now they want to know the angle here. They take a 10 angle equal HC going down. That's a minus HC divide R. Okay. That you're able to calculate the angle. 10 minus of minus HC divide to R. IT will be lead VT 0 degree. Now, try to see can we do that thing. Okay. That's what when you're working on left volt, that's coming from left volt. Okay, you can get a V voltage here. Okay. And that will be R. That will be XC. XC equal XC total. Okay. Now what I want? Total impedance G total. That means they want to calculate the total resistance. And we already know XC and R, you cannot add them up. You must be using the formula. Okay, square root R square plus XC square. Okay. And total current I equal V total here divide to total resistance. Okay, GT. Voltage VR. If you want calculate VR, take IR or IT or IC, that's only one current, time R. Okay, and you want to calculate the voltage across VC. VC equal IC times XC, and IC, IT will be the same. Phase angle between V total and I. Okay. Let's see. Angle will be equal 10 minus 1 of minus XC over R. That is the phase angle here. Okay. 10 minus 1 minus XC over R. IT lead VT by 0 degree. That means no phase. Okay. And let's see. VT and I, which one leading?
Aye.
You see right here. IT, lead VT 0 degree. Okay? That means no leading. This is a solution. That means the formula we already give it to you. Any question here? If I want to calculate the total impedance, you cannot adding up. You have to using square root R square plus XC square. And after you get total impedance, and you want to calculate total current, you take the VT divided GT. Okay? You want to calculate VR will be I times R or IT times R, same thing. VC IT times XC. And this is the phase angle. Okay, now, can you quickly doing that for me? To see who can get footing G total. Okay, G total. Square root okay. Total current equal V total divide G total. VR equal I total time R VC I total time GC. Okay, phase angle. You want calculate? They will be tan minus 1. Okay, of minus H C over R. You see that very simple. Only thing it requires understand the basic thing. Okay, we don't want to do with capacitor time charging, discharging. No, this is the AC. Okay, VT and I will be different zero. Now, the next one, HCR in parallel. Okay. This is the total. And this is actually, these are in parallel. First thing, if I see on that one, I can see one thing we have to know for the circuitry. Then VR equal VC equal V total. Correct or no? That's telling you VC will be here. VR will be here. Total voltage will be here. Same resistor, right? So VR or equal VC or equal VT, you can get only one voltage. Okay? And now you see here, the difference will be IC and IR. This is the IC here. And that will be IR. Okay? That's a different current, but the same voltage. If you're looking on that one, I want to know the phase between VT and IR. Who can telling me?
Did
I
you
want
say,
to know
did you say the phase?
the phase.
90 degrees, right?
No,
180.
no. Now,
Oh,
in this circuitry, what we need to know. First thing, I see lead VC. That's the formula, right?
right.
I see lead VC.
But we can't see the resistance.
What are you talking about? Resistance.
Your marker, your editing board options are covering up the amount of the resistor.
Oh, that one, right?
Yeah, you know, the ink blots and stuff, and there you go.
Sorry.
That's okay.
Now, first thing, you up to this point, you know, I see lead VC 90 degree, correct?
Correct.
Okay. IR, VR, in phase. That's what's going on. That we already know. Okay. Now, in the parallel, so the voltage VC, VR, VT equal. That's a one voltage. So, from this voltage, now, they say the volt VT is the same own component. We already know that. Branch current IR through R in phase with VT. Okay. Now, VT and IR in phase. Why? Why they say VT in phase with IR? You telling me why I say VT in phase with IR? The thing is, you know, VR and VT same, right? This is VT right here. VR will be go this way. VR. go this way. VC, VR or VT, only one voltage. Only one, same thing. Okay? So IR and VR in phase. Okay? So that will be telling you IR and VT also in phase. The thing I did, current I here, IR here, in phase VR, and VR and VT same. So that's why they say VT in phase with IR. Okay? That's what they say, number 2. Number 3, IC lead IR 90. How come?
Because it always does.
Who can explain to me why they say IC lead IR 90? Now I can tell you.
There's opposition, right?
Lead, that means different phase. Okay.
Because yeah, IC or IC is 270 degrees, and
Now we're not talking about that. We're just talking about the lead or the same phase. Okay. In here they're telling you IC lead IR 90 degrees. 90 degrees. How come they can say that? One thing you know, IC lead VC, right? That's a formula when they're talking about capacitor. IC lead VC 90 degrees. So that also telling you IC lead IR 90 degrees. The thing is, IC lead VC, that means IC also lead VR. Okay? And VR and IR will be in phase. That's why they say IC lead VC 90 degrees. 90 degrees. So the current I through C lead VT by 90 degrees. Okay? That's very simple. I see here lead VC 90 degrees. VC, VT, VR, same thing. So that they're telling you, I see lead VT 90 degrees. If you understand on that thing, next SL circuitry will be the same. First thing, you have to know when they're talking about XC, okay? That means they're talking about capacitor. IC lead VC, this is 90 degrees, that formula. IR, VR, in phase, resistance have no phase, okay? That's only 2 things in order to come up with something else. Okay, now, try to understand on that thing. For parallel, okay, this is a rectangular coordinate. First thing I draw for R, IR must go this way. Okay, and we already know. They say IC lead IR 90, so that's why they go up. They're not going down. Okay, right here, IC lead IR 90 degree. So they're going up. And then you have to draw the phase yaw. Okay, first thing you have to draw for IR. And I see going up, so that's why you're going up. And you try to draw, okay, this is total, I total, okay, and basically you understand a I total equal what? Equal square root of IR square plus IC square. That's a Pythagore, okay, in the map. That's why here, okay? Okay, you want calculate the IT. You have to take square root of IR square plus IC square. Okay, if you want calculate IC equal the total voltage divided HC. You want calculate IR total voltage divided R. Okay, if you want to calculate the total impedance, they will be take a VT divide IT. And the phase angle here, okay, they can be tan of theta equal IC divide to IR. That's in the math. So if you want to calculate the phase angle, will be tan minus 1 of IC over IR. So basically, I really like you able to understand for RC in theory and RC in parallel. Okay. Now, if I, for this circuitry here, you understand R here, IR here. IC here. This is the I total. Now, calculate the branch I current IC. How can we calculate that current IC? Go back here. IC equal total voltage divide IC. IR total voltage divide R total current. Remember, you cannot adding IC to IR. You have to using the formula square root IR square plus IC square. Okay, and if you want to calculate the total impedance, that means you combine R and C. Then you can calculate equal VT divide IT. Okay, and the phase angle. Tan minus 1 of what? IC over IR. You see that this is very simple. If you understand, get it done very quickly. Okay. That one the same thing. However, we already calculated for you. You have to get the time to go into that and you try to do calculation. Okay, you can get the same answer like we get here. Okay, now basically you already go to halfway of the program. Okay, this is a lot part of the program you try to get through it in order to get a completion certificate for the program. The number of students in that school doesn't matter how many. Don't have to be more or less. Why? If you not pass in Taekwondo, you cannot register for Taekwondo. So now I spend a lot of time trying to control the student to see who get the thing done in order to get the certificate. Okay. Also, I telling you, one student, they go to the mid city, ask for the certificate for Taekwondo. But the mid city cannot telling you can get certificate Taekwondo or not. If I already report at the end, then where you asking certificate Taekwondo, you qualify, they given to you. If they see your name not qualified in the list, and they have to ask me. The thing is, the students say I'm get enough hour. I supposed to get certificate. However, this is a technical program. If you cannot get through the technical training in the program, forget it. We cannot help you out. Same thing. You on Taekwondo now. I try to speed it up. Next, maybe 2 more weeks. Then I will be work with you. Teach you on the fundamental digital circuit. Now I just try to helping you. So you able to try to get AC1, AC2 on the level. Done as much as we can. I not expect 100%. I expect you 70%. Good enough. Okay. So any question up to this point? If you understand RC, then no problem for RL. So you get any question to me? Anything. If you not quite understand, then you can text to me. I can on Zoom with you. Try explain again. Make sure you understand. However, you have to study. This is we already we try to summarize what you need to know. In the textbook, they get too many things. We don't care. So, do you get any question, anything?
No, I think I'm good.
Not right now. I'm gonna have plenty of questions for you though.
Okay, again. Okay. Next week and one following week, I try to finish as much as I can. AC.
Okay, thank you.
Okay. And then after that, I will be meet you about digital fundamental. That will be on Monday in the class, room 240.
Okay.
Okay. The thing is that you have to working in person with me. Easy for me to helping you. Okay.
Okay.
How to build the circuitry, how they working, how to write the program, anything. We have to helping you. You know.
Okay, do you want us to download the programs to our computers this weekend?
Download what?
The program C++ and Visual Basic?
Yeah, we already talking to you on the last semester. Not talking. I'm not telling you to upload it. However, I will re-upload again. Okay? To make sure everyone have to upload it. If I'm telling you one thing, the easy way to learning is reading over. Before, I'm working engineering. Basically, I'm electrical engineer, hardware engineer. However, 1990, company given me the project using C++. They told me if I cannot get through it, then they lay me off. So after 1990, they start a C++ program. Everyone learning. Okay. So I bought the book also, but I don't understand. And when they want me to do that project, if not get through, they lay me off. So I go to Microsoft certificate in La Jolla to study C++. 1 week, 5 days. $1,500. However, company pay for. I go to school 5 days. Only thing I can get coffee and donut in the morning. 8 hours. But after the 1 week, I still cannot understand. So now I keep reading the book, reading over and over. Up to a certain point, I can understand everything on that. I never know. Later on, I can teach C++ very long time ago for this program. If you not understand, you cannot teach it. Like the same IAC circuitry here. It's hard for everyone. However, if you keep going over, you're working on thinking, then I guarantee you'll be okay. Later on, you want to go to be an engineer. That's not a problem. If you can understand what we given to you in here. Okay? So next meeting, we try to go faster than get RL done. Okay? Now, we will be take a quiz. Okay? Make sure you go to website, take your assignment, download report, and I given to you the time you have to be done before Sunday.
Before Sunday?
That means you have to done before Sunday.
Okay.
Okay, the thing is, this time after you upload it, then the next quick is telling you what grade you get. You have to get C or B or A. If you get a D, I let you try to working again on that. Okay? I don't want your guy get a problem if you really want to learn. However, make sure you have to understand. Okay, now.
By Sunday midnight?
Yeah,
Okay, thank you.
okay, now I get the cat. Oh, sorry. That Q, is it AC? No. We get your AC. On number 420 milli, I think that will be farad.
Thank you.
Any question, anything?
No, that was
The
good.
thing is, this first quiz here in very general. Okay? We'll see what's going on, what happened. Just upload it after you're done.
Okay, sounds good.
Okay? So, good night, everyone.
Good night. Have a good weekend.
Good night, sir.
Yeah, thank you. Okay? We'll stop now.